And now let's see one more examples on sketching square root functions. So this time, let's say I have another function fx with square root of 1 minus 4x minus 3. So again, we begin with the simple steps in graph sketching. So what we have here is that first we start with the type. So the type of the functions, what we find out is that memang fulfill, where you can see the a is referred to positive 1, the number that multiply with our square root, the m refer to negative 4, the c is referred to positive 1, and the k refer to negative 3. So memang bentuk dia fulfill. Next, step 2, we want to decide the shape of the graph, and what we need to do is that based on the function, we identify. We've noticed that we have, based on the terms inside the square root, I find out the coefficient of x is negative. And then I find out that the square root I have here is a positive square root. So how am I going to decide the shape is that once again, we base on the shape of having positive x and positive square root. This is the shape. So now what is the changes I want to make is that from positive x, I want to have negative x. Or I should say the coefficient, the positive coefficient of x change to negative coefficient of x. And what is the changes will happen on the x? So if I want to change sign on the coefficient of x, then it will involve of flipping the graph left, right. So from positive coefficient of x change to negative coefficient of x, I will need to flip the graph left, right, and it gives me the shape in the way of. So I flip horizontally, and this is the shape that I have. So now I have identified the shape of the graph in step 2. Next, I will go on with step 3, where I want to decide the coordinate of the special point, this point here. How are we going to decide? So the special point here is referred to the vertex. So how we calculate the vertex from the function is just as simple as, first, I refer to the linear function inside the square root 1 minus 4x. I make it equal to 0, and I get x equals to 1 over 4. And this x value is the x coordinate for the vertex. Then the corresponding y coordinate just refer to the constant net minus 3. So the y coordinate will be y equals to minus 3. As a result, I have the vertex coordinate as 1 over 4 minus 3. Once I reach until here, once again, guys and girls, from here, by right, it can go on with the next step that we decide whether the x and y intercept exists or not. Also, at the same time, by right, you reach until this step here, you should be able to observe what is happened to be the domain and range of the function. Without having the full graph sketched out, I can know the domain and range, where based on this vertex point here, if I want to refer to domain, I would like to see how far my x can travel to left and right. So the x value at this special point is 1 over 4, and it can go all the way to the left-hand side, endlessly on the left-hand side, which means that it will reach until negative infinity. Therefore, the domain will be negative infinity until 1 over 4 and include 1 over 4. Then the range, I want to see how far my graph can travel vertically. Dia boleh naik setinggi mana, turun serendah mana. So based on the reference point in the vertex here, I noticed that I can from negative 3 all the way go up until infinity. And therefore, it tells me that the range is negative 3 until infinity. Just in case you want to find out what is the domain and range, we can reach the domain and range from this part here, the step 3. Then without further ado, let's refer to step 4. We decide the intercept on x and y axis, if let's say they exist. So what we do here is that make use of the special point that we have. We try to do a rough sketch. So the special point will happen to be at the coordinate 1 over 4, negative 3. So when the time I do rough sketch, you find out that I will happens to have the graph cut at the y-axis, cut at the x-axis. So this indicates that I have x and y intercept exist. However, please be aware, in here I call it as a rough sketch because this may not be the correct positions. This may not be the correct position of the y and x-intercept when the time you do this rough sketch here. Maybe the y and x-intercept is on down here, maybe. The idea here, the rough sketch, is just for you to identify, is it possible to have x or y intercept? But what is the what is the correct location, the coordinate? It will be decided after the calculation. Just again, here is just for us to identify the x and y intercept axis. Go on. What we do the next is that we do the calculation of x and y intercept since we notice that it exists, although we don't know what is the value. So we begin the calculations of the y-intercept. I find out that y-intercept can be calculated when x equal to 0. So by substituting x equal to 0 into the functions here, I will have the fx equals to -2, which means that my y-intercept is -2. So my graph will cut y-intercept at -2. So by right, you tengoklah, ini intersection yang saya buat dalam rough sketching sudah salah. Tapi tak apa. Dia hanya sekadar untuk bantu kita tahu y-intercept wujud ke tidak. Sketch salah dalam rough sketching ini tak apa. Nanti kita sketch balik betul according to this value that we have. Then for x-intercept, we will have when the time the y equals to 0 or the fx equal to 0, I find out that I solve, I get x equals to -2. So once again, I find out that my rough sketching bagi saya kedudukannya salah. Tapi tak apa. This is why we need to do the calculation. The rough sketching untuk identify intercept axis ke tidak. And finally, make use of this info here. We sketch our graph. When now this graph here, we sketch properly the x and y intercept positions. And therefore, we complete our graph. And again, remember, label your xy axis, label the origin, label the graph. The graph is called as function f here again. The y and x intercept if exists. Then at last, the special point, the vertex. Therefore, this is how we have done our graph sketching for the second example in square root functions.